Welcome to the Texas A&M University Agricultural Research and Extension Center at Beaumont. This video explains the various steps and stages involved in rice cultivation and production processes used by the specialty rice breeding program in the research field. Land preparation is the first step in rice cultivation, requiring multiple rounds of plowing and rototilling to break up compacted soil, improve aeration, and create a fine, well-prepared rice field. This process also helps cover organic matter and weeds, eliminates pests, and establishes a uniform surface for water and nutrient distribution. The next step is to level the field. Field leveling can be either traditional or precision leveling. In our research field, precision leveling with lasers is performed before dividing the field into blocks. This process also helps to ensure proper water distribution and improves soil moisture retention. Creating a layout in the rice research field is a vital step that reduces spatial heterogeneity and represents an effective experimental design. This can also minimize border effects and facilitate proper intercultural operations. An appropriate field layout also ensures that experiments are reproducible and results are accurate, often involving specific designs. The mechanical plot seeder for direct seeding rice is considered the most effective research method, especially when uniform seed distribution is crucial. Consistent seed spacing and depth decrease a major source of variability between plots. Accurate uniform seeding leads to more reliable seedling emergence and establishment, which are crucial for comparing early growth stages of different genotypes or treatments. The planter is explicitly designed for precision planting in field trials and plant breeding research. Once the seed sowing is completed, the next step is to flush irrigate the field. Flush irrigation helps to position the seeds properly in the soil and provides a better environment for germination. During the germination period, regular checking of the field's moisture level is necessary. Planting density and seedling vigor can be observed at the early seedling stage. About 6 to 7 weeks later, the necessary amount of nitrogen or urea fertilizer is mechanically applied. The water level should be maintained 4 to 5 inches above ground to ensure permanent flooding. This permanent flooding ensures proper rice plant growth and helps control weeds. During the tillering stage, it is essential to check the plant's health and growth progress regularly. Heading date, specifically when 50% of rice plants have emerged panicles, is a critical milestone for breeding programs because it is a key determinant of a cultivar's adaptability and maturity. This timing controls the duration of the reproductive phase, influencing overall yield, grain quality, and the cultivar's suitability for a specific growing season and region. After flowering, the panicle emerges from the stem, becomes visible, and enters the grain-filling phase. During this time, grain development continues within the panicle, with the number of potential grains having been set earlier in the reproductive phase. When rice grains turn yellow, and 80 to 85% have ripened, it's time to harvest. Harvesting at this point maximizes yield and quality. Harvesting too early can result in immature grains. Harvesting rice is the final and essential step of the rice cultivation process. We use a combine harvester to harvest rice. The adoption of combine harvesters has transformed rice farming. These machines enable faster harvesting, lower labor costs, and often better harvest quality. The rice combine harvester is an automated machine that combines harvesting, threshing, and cleaning in one operation. It is suitable for the local conditions of major rice-producing regions. For research, a combine harvester can be used to collect plot-level yield data, and harvested grain can be separated for each plot. This setup enables detailed analysis of harvest moisture content and yield, allowing comparisons across different varieties or experimental conditions. It also provides opportunities to examine factors like technical efficiency, economic impact, and optimal operating parameters. After harvesting, rice samples are air-dried to 14% moisture content and stored for further analysis. Thank you for visiting us virtually. It is a great pleasure for the Specialty Rice Breeding Program.